قبل ما نبدأ المحاضرة.
عليكم دكتور.
وعليكم السلام، تفضل.
من بعد إذنك عندي اختبار أنا هلا الساعة 4.
طيب، اختبار عادة بيكون قصير، ربع ساعة 10 دقائق. سوي أدي الاختبار وارجع.
تمام، بس أعطيك خبر.
أوكي، بسيط.
شكرا.
بالتوفيق. طيب، بسم الله الرحمن الرحيم. إن شاء الله we will start with the second derivative test subject. This is in also in chapter or tutorial number 3. So we have after that we have some optimization problem in this tutorial. Okay, the second derivative test using to find local maximum and minimum for stationary point. So if we have x equal a as the stationary point, look at this. This means x equal a stationary point, because when substitute a in f prime equals 0. So if a also substitute in f double prime and we have negative, so we have concave down, because f double prime negative, so we have concave down like this, concave down. So this a means the local maximum, because we have concavity to down, so the maximum point must be at x equal a. Okay, now if we have f double prime on substitute a in f double prime and we have positive value, so we have concave up. This is positive, so we have concave up. So this means the a and FLA, this also FLA, this means no a and FLA, this is the local minimum point. Okay, exercise about this. Example, find the local extrema of f of x equal x to the power 3 minus 3x square plus 2 using second derivative test. The solution: if we have f of x, find f prime to find the stationary point. So we have 3x square minus 6x equals 0. Take x as common factor, so we have 3x minus 6 equals 0. Now we have x equals 0 or 3x minus 6 equals 0. So we can conclude the x equal 2 by move the 6 to another side and divide by 3. So we have 2 stationary value. Now this is stationary value, but we need to determine which one f of x has local maximum, at which one local minimum. So we need to substitute what? X equals 0 in f double prime. What's the value of f double prime? Look at this. F double prime of x equal 6x minus 6. So substitute 0 in f double prime, we have 0 minus 6, so this is equal -6 less than 0. This means f of x has local maximum, because the value of fw prime negative. This is in 0 and f is 0. This called local maximum. Substitute f is 0 in f of x, so we have 0 minus 0 plus 2, so we have 2. This is for the first stationary point. The second one, substitute 2 in fw prime equal 6 multiplied to 12 minus 6. This is positive, equal 6, positive. So the f of x has local minimum at 2 and f at 2. This equal 2. Substitute 2 in f of x. We have 8 minus 12 minus 4 plus 2, so we have -2. Okay, this is the local maximum and minimum by using the second derivative test. Any question? Now we must go to the optimization problem. We have 4 examples. Look at the first one. In the optimization problem, in general, we have function or relation. We need to find the maximum or minimum for this relation, and we have must be given the relation between x and y to convert the q or any function in the single variable, because cannot find the maximum or minimum for function have x and y, okay, or relation have x and y. So we need to convert, in this example, q equal x squared multiply y. We need to convert this q to with respect only with x, okay. So we need to find two number x and y, must be have the relation, must be determined. This is need maximum or minimum, and we have the relation between x and y, okay. Now in this example solution, firstly we have the q x squared multiply y, and we need to find xy that satisfy maximum of a q. Now we must using the relation x plus y equals 6. This is given in example, so we can conclude y equal what? 6 minus x. This relation using to substitute in y and convert the q as single variable. So we have 6 minus x, the q equal 6x squared minus x to the power 3. The first derivative of a q equal 12x minus 3x squared, like this. This is equal what? Equal 0. Take x as common factor, so we have 12 minus 3x. This is equal what? 0. Now we have x equal 0, or 12 minus 3x equals 0. So we have x equal what? 4. Now we have two stationary value. The first one 0 and the second 4. The 0, this is fail because we need x and y positive number, two positive number. Look at this, we need two positive number. So 0 not positive, 0 0. Now we need to check at x equal 4 the q maximum or minimum by second derivative test. We have 12 minus 6x. So substitute at the second derivative test the value 4. We have 12 minus 24. So we have negative 12 less than 0. So the q, we can conclude that the q is maximum at x equal 4. At x equal 4. Okay. To find the y, using this y, what the value of y? 6 minus x. So we have 6 minus 4. So the y equal what? 2. So y equal 2. This is the value of y. This is the value of x. This is the two value. The summation equals 6 and satisfy the maximum value of q. Okay. If we need to find the q is maximum at 4 square, the value of x. This is the q. 4 square multiply, this is x and this is y. 16 multiply 2, so we have 32. This is the maximum value for q. Any question? Any question? Okay. The second example, find the dimension also rectangular garden. We have x and y. Two dimension for rectangular, x and y. For greatest area, so we need two area equal always for rectangular x multiply y, and greatest mean the maximum area for a that equal x multiply y. That can be fenced of 300 meters. So the value of fenced, this is the long side around the rectangular garden. So we have x plus y plus y. This must be equal what? Equal 300. So this is the relation. This is the function, and we need maximum for this function. Must we have 3 value? The function a, q, m, b, any with respect to x and y, we need to determine the value of x, or that maximum of area or minimum, and must we have the relation to convert the area in one variable. The solution here, we have rectangular. Okay. This have two dimension x and y. So we need to maximum area that equal x multiply y. To convert this area as one variable, we have a fenced equal x plus y plus y, that must be equal 300. So we have 2x plus 2y equal 300. So 2y equal 300 minus 2x by divide by 2 we have y equal 150 minus x, like this. Now, the area equal x multiplied by 150 minus x. So, after simplify, we have 150x minus x squared. Find the derivative of area. We have 150 minus 2x. This is equal 0. So we have x equals 75. We have only one critical point or stationary value. Now, AW prime equal what? Negative 2. After substitute, 75. Also, we have negative 2. So we have in the second derivative, we have negative value. We can conclude that A is maximum at x equal 75. And the value of y equal 150 minus x. So we have 150 minus 75 equal 75. So the y equal 75. The value of area, x multiply y, so we have 75 multiply 75 by calculator, area equal 5,625. This is the maximum area for the rectangular garden that have fenced 300. Must be square. X and y are equal. Any question? Look at this example. Yeah, x and y here in this example must be equal. In this example, look at this example, new example, rectangular garden with area. So this is fixed area, area equal x multiply y equal 75. So the area of the garden that equal x multiply y equal 75 is to be surrounded on 3 sides by brick wall costing $10 per foot. Okay, so the cost of this side 10x, the cost of this side 10y, the cost of this side 10x. This is the 3 side. Okay, and one side the cost 5. So this is the cost 5y. 5 foot be $5 per foot. Find the dimension. So we need to find x and y. The garden such big, the cost material, cost in general, the cost must be minimized. Okay, must be minimized. Wait. So we need minimize the cost. The cost equal what? 10x plus 10x plus 10y plus 5y. This is the cost. Because in this side we have the cost $10 per foot. So we have 10 multiply x. In this side 10y, in this side 10x, but the fourth side 5y. Okay, so the solution, we have rectangular with X and Y. Okay. We need to put the wall around 3 sides like this. Okay. So the cost, we have here 10x, we have here 10y, and here 10x, but in the fences, the fourth side, the cost 5y. Okay, and we need the minimize cost, so we need minimize the cost that equal 10x plus 10x plus 10y plus 5y. So the cost equal 20x plus 15y. What's the value of y? Y, the area of this area is fixed. X multiply y equal 75. So x multiply y equal 75. So the y equal what? 75 over x. Or we can put it as 75 في x to the power negative 1. So substitute this y here. So the cost equal 20x plus 15 multiplied by 75x to the power negative 1. Multiply 15 with 75. We have 1125 x to the power negative 1. This is the cost with respect to x only. Now we can find the derivative. This equal 20 minus 1125 x to the power minus 2. This is equal 0. So we have 20 equal 1125 over x squared. So the x squared equal 1125 over 20. This equal x squared equal, after divide 1125 over 20, we have 56.25. So we have x equal, by taking the radical, we have two values, negative 7.5 and x equal positive 7.5. But negative, remove it because this is dimension. How can the dimension or length of the wall equal negative? Must be positive. Okay. Now, by second derivative test, we need to check this is positive or negative. So we have positive 250 x to the power negative 3. After substitute the 7.5, this equal 250 7.5 to the power negative 3. So this is positive. Positive multiply positive, positive. Since this is the CW prime positive, so we can conclude C is what? Minimum at x equal 7.5. So if x 7.5, what's the value of y? Y equal, this is y, 75 over x, so 75 over 7.5, so we have 10. So the value of x equal 7.5, the value of y equal 10. This is the dimension that minimum cost for the garden. Any question? Any question? The last optimization problem here, a canvas wind shelter for the beach has a back. So the canvas has back, 2 square side. Square means the dimension XX, and top. So we have back. Okay, this is back, 2 square side, this one and this one, number 3, 2 and 3, and top, this is 4. So we have 4 side, 4 surface area. Find the dimension for which the volume V equal X multiply X multiply Y. اللي هو طول بعض بالارتفاع الفوليوم الحجم. This is must be equal to 150. So we have x square multiply y equal to 150. This is fixed. And the requirement least, this is minimum amount of canvas. Amount of canvas, the C equal 1 كمية القماش المستخدمة لهذه الخيمة. في عندي 1 اللي هي back, 2 square side اللي هو 2 plus 3, and the surface area of top. So we have 4 surface area. So the C equal what? 1 x multiply y. Number 2 x with x square plus number 3 also x square. The top x y. So we have C equal 2x square plus 2xy. This is the cost we need to minimize. Find the x and y that satisfy minimize. Okay, go to the solution. The solution. So we have canvas with square side, okay, so we have back, to left, right, side, and top with dimension x and y. And we have a volume that equal x multiply y equal 250. So we have x square multiply y equal 250. So the value of y equal 250 في x to the power minus 2, because this is over x square and above the x square on the numerator, so the exponent equal negative. Now we need the minimum of the cost of canvas. So this is equal 1 plus 2 plus 3 plus 4. So the C equal 2x square plus 2xy. Okay. Now, what's the value of y? The value of y equal 250 x to the power minus 2. So the C equal, after simplify, 500 x to the power minus 1. Now, C prime equal 4x minus 500x to the power minus 2. This is equal what? Equal 0. We solve this equation. We have 4x equal 500 over x squared. By cross product, we have 4x to the power 3 equal 5. By divide by 4, x to the power 3 equal 125, and then x equal 5. So we have only one critical point. Find the a double prime. This equal what? 4 plus 1000 x to the power minus 3. After substitute the 5, we have 4 plus 1000 5 to the power minus 3, positive plus positive, so we have positive. So we have minimized for the C, for the C. So C is minimum at x equal 5 and y equal, this is the value of y equal 250 over x squared. So y equal 250 over x squared and 5 squared 25, and this is equal 10. So x equal 5 and y equal 10. This is the dimension for the canvas that satisfy minimum cost of the canvas. Okay, any question? Any question? And at this example, we finished the tutorial number 3, the application of derivatives. طيب الآن go to the tutorial number 4. In tutorial number 4, we have 4 main subjects. How can find the product of two, the derivative of a product to function, quotient of two function. So this is called product rules and quotient rules. Also, we have the chain rule and implicit differentiation. Okay, this is 4 main subjects. The product rule if we have f of x multiplied by g of x and we need to find the derivative of this product, this equal the derivative of the first multiplied by the second plus the first multiplied by the derivative of the second. Example about this rule: find f prime of x. Number 1, f of x equal 6x squared minus 1 and x minus x to the power 3 all to the power 5. Number 2, f of x equal radical 2x plus 1 multiplied by 9x squared minus 5x. Now, the first derivative of f of x equal must be derivative the first. This is equal 12x multiplied by the second x minus x to the power 3 all to the power 5 plus the first and multiply by the derivative of the second equal 5x minus x to the power 3 to the power 4 and derivative inside the brackets like this. So this is the derivative of the second and this is derivative of the first. Okay. Number 2, the derivative of radical, this equal 2 over radical 2x plus 1 multiplied by 9x squared minus 5x plus the radical as it is without any derivative and the derivative inside the brackets, the second equal 18x minus 5. Any question? So this is the rules. Just find the derivative of the first, fix the second, plus fix the first, find the derivative of the second. Okay. Example: find an equation of the tangent line to f of x equal 3x plus 1 multiplied by x plus 2 all to the power 3 at x equal negative 1. To find the tangent line, we must have the point, slope, and we can write the equation. So, firstly, find the point, find the slope. After that, we can write the equation. Okay? To find this point, this means we need x1 and y1. So this is equal what? Minus 1 and f in negative 1. So f in negative 1 equal 3 multiplied by negative 1 plus 1 multiply negative 1 plus 2 to the power 3. This equal negative 2 and multiply 1. This is equal negative 2. So the point negative 1 and negative 2. The slope, firstly need to find the f prime because the slope at x equal negative 1. This means f prime at negative 1. So must be find f prime. This equal 3 multiplied by x plus 2 to the power 3 plus 3x plus 1 multiplied by 3x plus 2 to the power 2 multiplied by 1. So f prime at negative 1 equal 3. Substitute negative 1, we have 1 to the power 3, 1 plus substitute negative 1, so we have negative 2 multiplied by 3 multiplied by 1 and 1. So we have 3 minus 6 equal negative 3. So the slope equal negative 3. Now, to write the equation, we have the slope m equal negative 3 and the point negative 1 and negative 2. The equation y minus y1, this is y1 and this is x1, equal m x minus x1. Y minus y1, this is mean plus 1, m negative 3, x plus 1. So we have y equal negative 3x minus 3 minus 2. So y equal negative 3x minus 5. This is the product rules. The second rules, the quotient rule. If we have f of x over g of x and we need to find d over dx, this equal the f prime multiplied by g minus f of x multiplied by g prime over g x square. So the numerator derivative multiplied by denominators minus now swap f multiply g prime, okay, over g square. This is if we have f over g, but if we have a over g, for example constant over g, this direct we can apply this one or directly negative a g prime over g lx square, like this. Okay, example about this. Example, find y prime. Number 1, y equal 3x square minus 12 over 7 minus x. Number 2, y equal radical x minus 1 over x square minus 2. Number 3, y equal, for example, number 4 over 2x plus 5. To find the y prime, we apply the quotient rules. The derivative of the numerators equal 6x multiplied by denominator 7 minus x minus the numerators multiplied by denominators minus 1 over 7 minus x all square. So this is the first derivative of the y. Also y prime here, the derivative of radical x minus 1, this equal 1 over 2 radical x minus 1 multiplied by x square minus 2 minus the radical x minus 1 multiplied by the derivative of denominator 2x over x squared minus 2 all square. The derivative of the third equal, we can doing directly minus 4 the derivative of denominators 2 over 2x plus 5 denominators squared. This means minus 8 over 2x plus 5 squared. Any question? Any question? The third subject in this chapter, the chain rule. We have two rules in the chain rule. Number one, if we need to find the derivative of composition function f GLX, so we must find the derivative of f, substitute g in f prime and multiply g prime. So we need to find f prime and g prime, but in f prime we substitute also GLX. GLX. Example about this. Let f of x equal 5x to the power 3 minus x squared and GLX equal 7 minus radical x, and we need to find f composite g lel x d over dx. The solution to find d over dx for f GLX, this means find the f prime, substitute GLX, multiply g prime. Now find f prime of x equal 15x squared minus 2x. Now substitute g in f prime, so we have 15g squared minus 2g. What's the value of g? This is the value of g. Substitute here for f g equal 15 multiplied by 7 minus radical x square minus 2, 7 minus radical x. This equal, what's the value of g? This is equal 15, 7 minus radical x square minus 2, 7 minus radical x, and g prime equal minus 1 over 2 radical x. This is the derivative of g. Derivative of 7, 0. Derivative of radical x, 1 over 2 radical x with negative, because we have negative sign. The second rules for the chain rule, if we have two functions, one with respect to u and u with respect to x. Okay, so if we need to find dy over dx, must be found dy over du and multiply du with dx. Example about this, let y equal 5 over u minus 1 and u equal radical 2x plus 1. And we need to find dy over dx. The solution, dy over dx equal dy over du multiply du over dx. So dy over du, this equal minus 5 over u minus 1 square multiply du over dx, this is equal 2 over 2 radical 2x plus 1. After simplify, we have negative 5 over u minus 1 square multiplied by radical 2x plus 1. Now, substitute the value of u, so we have dy over dx equal negative 5 over radical 2x plus 1 minus 1 all square radical 2x plus 1. So this is the value of dy over dx. Any question? The last subject in this tutorial, implicit, and this is very important, implicit differentiation. We use implicit differentiation if we have, for example, x square plus y square equal xy, maybe y inside the radical plus x equal 3x square, like this. If we have y as exponent negative or lesser than 1 in radical in denominator multiply with x, so we use the implicit differentiation. Look at the implicit. If we have, for example, x squared, what the differentiation? X squared. The differentiation of x squared equal what? Equal to x. Okay? But if we have y squared, the differentiation, the derivative of y squared equal also to y. But when find the derivative of any y must be multiplied by y prime. Another example, if we have, for example, 5x, the differentiation 5. But in 5y, the differentiation 5, okay, but must be multiplied by y prime. When find the derivative of y, after find the derivative of y by rules must be multiplied by y prime. Okay. Also, if we have 3x to the power 4, this equal 12x to the power 3. In y, this is equal 12y to the power 3, but must multiply by y prime. Okay. Now, example, find the y prime or dy over dx. This is the same value, 4x square plus y square equal 5. The solution, if we need to find the y prime and we have y square, this is implicit differentiation. Find the derivative of 4x square equal 8x plus find the derivative of y square equal to y, but must be multiplied by y prime. The derivative of 5, 0. After find the derivative, put it the y prime, all terms in y prime on the left and other terms on the right. So we have 2y in the left, 2y prime on the left, and other terms on the right. After that, divide by the coefficient of y prime. Divide by 2y. If we divide by 2y and here 2y, so we have y prime equal minus 4x over y. This is the y prime. So the value of y prime here equal negative 4x over y. This is the value of y prime. Another example. Any question? Any question? Okay, go to another example. We have x y square minus x equal 5y plus 2x square. The solution, look at this. This is multiplication. Multiplication, so the first derivative multiplied by the second plus the first multiplied by the derivative of second, 2y, y prime, minus the derivative of negative x, negative 1 equal the derivative of 5y equal 5y prime, the derivative of 2x equal 2x square equal 4x. Okay, this is for derivative of a product because this is a product. Okay, now we have two terms in y prime. We have 2xy y prime, this one, and we have this one, minus 5y prime. Must be move it here, and negative 1, and this one negative, move it to another side. So we have 4x minus y square plus 1. Take y prime as common factor, so we have y prime equal to xy minus 5 equal 4x minus y square plus 1. So we have y prime equal 4x minus y square plus 1 over 2xy minus 5. This is the derivative y prime. Any question? Another example. Find an equation of the tangent line to the curve given by y squared minus xy minus x squared equal 1 at 1 and 2. Find the values of the tangent line as given in the point. After that, but the point already given, x1 and y1 equal 1 and 2. This is the point given in example. Now we need to find the slope. The slope, this means m at 1 and 2. This means y prime, and substitute x equal 1 and y equal 2. Now, this equation to find this relation to find the y prime, 2y prime minus the derivative of x1 multiplied by y plus x multiplied by the derivative of y prime minus 2x equal 0. So we have 2y prime minus xy prime. This equal 2x and plus y. Take y prime as common factor. This equal 2y minus x. This equal 2x plus y. By divide all of these, divide by 2y minus x. This is the coefficient of y prime. We have y prime equal 2x plus y over 2y minus x. So the slope equal at the point 1 and 2 equal 2 multiply 1 2 plus 2 over 2 multiply 2 4 minus 1. So we have 4 over 3. Now we can write the equation. The slope equal 4 over 3 and the point equal 1 and 2. This is x1 and y1. Y minus y1 equal m x minus x1. So we have y minus y1 equal to m 4 over 3 x minus 1. Y equal 4 over 3x minus 4 over 3 plus 2. So y equal 4 over 3x minus 4 over 3 plus 2 over 3. So this is minus 4 over 3 plus 6 over 3. So we have 2 over 3. This is the tangent line. Also, we can find the slope of the tangent line. No need to find the example. Ask you to find the slope. So just find the slope of the tangent. For example, like this. Example. Find the slope of the tangent line of the graph of x to the power 3 minus radical 2y equal 3y squared plus 9x minus 6 at the point equal -1 and 2. To find on the slope, we need to find the slope m at the x equal -1 and y equal 2. So this is mean. Find the y prime and substitute x -1 and y equal 2. This is the relation. The derivative equal 3x squared minus the derivative of radical 2y equal 2y prime over 2 radical 2y equal 6y y prime plus 9 and minus 6 equals 0. So we can move this one here and this one here. So we have 6y y prime plus 2y prime. We can remove 2 with 2. 2 with 2. So we have y prime over radical 2y equal 3x squared minus 9. Take y prime as common factor. So we have y prime equal 6y plus 1 over radical 2y equal 3x squared minus 9. So we have y prime equal 3x squared minus 9 over 6y plus 1 over radical 2y. Now substitute the point -1 and 2 in y prime. We have 3 minus 9 over 12 plus 1 over radical 4 equal 2. So we have y prime equal -6 over 12 plus half equal 25 over 2. So we have denominator of numerator. So we have -12 over 25. So the slope equal -12 over 25. This is the slope of the tangent line for our example. Also, we can ask you about the horizontal tangent line. Find the point on the relation that satisfies horizontal tangent line. Example about this. Find the points on the graph at which the tangent line is horizontal and the relation equals 6y plus x to the power 3 minus 3y squared equal 12x. This is the equation. We need to find the horizontal tangent line, the point that satisfies horizontal tangent line. What's the meaning horizontal tangent line? Horizontal tangent line means the slope. So this is equal y prime equal what? Equal 0. The slope equals 0. The y prime equals 0. We need the value of x. Yes. This relation, the derivative of 6y prime, the derivative of x to the power 3 plus 3x squared, the derivative of negative 3y squared negative 6y prime equal 12. The derivative of 12x. 6y prime minus 6y prime equal 12 minus 3x squared. Take the y prime as common factor, so we have 6 minus 6y equal 12 minus 3x squared. By divide over, so we have 6 minus, we have 12 minus 3 x squared over 6 minus 6y. This is equal what? Equal 0. So we have, this is over 1. After cross the product, we have 12 minus 3x squared equal 0. So we have 3x squared equal 12. This means x squared equal 4. So we have x equal plus minus 2. Number 1, at x equal 2, substitute x equal 2 to find the y. We have 6y plus 8 minus 3y squared equal 24. So we have the quadratic equation 3y squared minus 6y plus 16 equal 0. When solve this equation, quadratic equation, the discriminant b squared minus 4ac, this equal 36 minus 4 multiplied by 3 multiplied by 16. This is less than 0. So this is not has real solution. Okay. So we don't have any point at x equal 2. We don't have any horizontal, any solution, real solution. Okay. At x equal negative 2, we have 6y minus 8 minus 3y squared equal negative 24. So we have 3y squared minus 6y and negative 16 equal 0. After solve this equation by calculator or any ways, like find it by general laws to solve the quadratic equation, we have y1 equal 3.52 and y2 equal negative 1.52. So we have 2 points, negative 2 and 3.52. This is the first point. At this point, we have horizontal tangent line. And the second point, negative 2 and negative 1.52. This is the second point. So This is the main application on implicit differentiation. Maybe find the y prime, find the value of slope at specific point, find the tangent line, find the point that horizontal for horizontal tangent line on this curve. Any question about this? Yeah, the same. But to find the slope, here we need to using the implicit differentiation. Okay. Any question? Now we finish chapter tutorial. Yeah, before we finish tutorial number 3, and now we finish also tutorial number 4. Tutorial number 4 have 4 main subjects, all of the new technique to find the derivative: product, quotient, chain rule, and implicit differentiation. This is very easy chapter, but is very important also. Okay. Inshallah, next week we will start with tutorial number 5. When finished tutorial number 5, we will open the TMA if you have any question about TMA. Okay.
دكتور
طب سمعون تفضلي.
معلش سؤال. حابة أعرف إيش الفرق بين الديريفاتيف والبرايم، يعني كيف الفرق بينهم؟
عيدي سؤالك لأنه كان الصوت يقطع، أنا ما سمعته. إذا أحد سمعه
قاعدة بقول
عيدي السؤال لو سمحتي.
أيوة، الفرق بين الديريفاتيف والإف برايم، لأني أحسها نفسها، بس لما أنت قاعد تشرح بحس في اختلاف، فماني فاهمة، بس هذه النقطة.
وأنا مش فاهم شو سؤالك صراحة. ما أبي قطع الصوت عندي، ما بعرف
دكتور.
يعني مو واضحة، يعني كلمة تروح وكلمة تيجي، مو واضح.
دكتور، هو نفس
تفضل.
السؤال اللي سألتك اللي هو the difference between derivatives
إيش
and the f prime، هو نفس السؤال اللي في الشات.
شو اللي برايم قصدكم فيه؟
ال f prime ما أدري عاد.
يعني قصدك العلامة اف برايم؟
أي نعم، أي نعم.
نمبر. إذا قصدك البرايم هو نفسه الديريفاتيف، هي فيرست، يعني فيرست برايم. إذا كانت 1 برايم هذا معناه فيرست ديريفاتيف، دبل برايم سكند ديريفاتيف، نفس المبدأ. البرايم هذه هي الخط، هذا بنسميه برايم، هو اختصار لا يعني لما نحكي find the first derivative هو نفسه كأنه بنوجد اف برايم. اوكي
تمام، يعطيك العافية.
حياك الله.
دكتور، محاضرة اليوم وأمس هل راح تكون في LMS اثنينهم ولا حق اليوم بس؟
كل المحاضرات اوريدي مسجلة موجودة في LMS، يعني من أول يعني موجودة تقريبا نفس التكنيك موجودة إلي يعني. فأنا حاطهم مسبقا يعني بحيث إنه أي طالب حاب يسبق أو تأخر زيادة عن اللزوم يعني يعرف يتصرف. خلينا نحكي. أي سؤال آخر؟ سامي بسأل إذا في جروب حطوا له إياه، إذا في لينك. أي سؤال آخر؟ أي استفسار؟ طيب إن شاء الله نلقاكم على خير الأسبوع القادم. الأسبوع القادم إن شاء الله راح نختم chapter 5. بعد ما نختم راح نفتح معكم TMA إذا في أحد عنده أي سؤال. يعطيكم العافية جميعا. دمتم في رعاية الله. إلى اللقاء.